Okay, so the topic for today is STP, which is one of the topic for CCNP. Okay, just one of the topic. I don't say STP. The standard STP is one. Okay, so you along with STP you have RSTP and MSTP. So I cannot complete all the three in one class. So I'll show with the first one, and the next few things I'll show in the next class. Okay. STP spanning tree protocol. It's a switching technology. So where do we see this effective? So let's say I have an office and requirement is to place some switches. Okay, I'm going to place some Cisco switches, layer 2 devices, something like this. I'm going to connect a cable between them. Okay, all are good so far. Now what happens is there is a requirement to add additional cables. So I'm going to add additional cables between them. Now what we see is we will see some looping happening. Okay, it's called as layer 2 loops. Now why do we see the layer 2 loops? Okay, let me show this the same scenario but by taking only two switches. Let me go to this and let me try to show you what is layer 2 looping. Okay, so as I told you, I have two switches, switch 1 and switch 2. When I have one connection, it's all good. Okay, so let's say I have a computer connected here to this switch, and I have a computer connected to this. So let's say this is PCB and this is PCA, computer A and computer B. So computer A is initializing some ping packet, or it is initializing some file transfer. Okay, so his data from this computer will hit on this switch, will send to this cable. It will be transmitted. It is received on switch 2. Switch 2 will send it to this, and then it reaches to PCB. Okay, all good so far. Now as I told, there is requirement for extra uh, packet transfer. So what my requirement is to connect one more cable. Now I connected one more cable. Now here is something where we can see some issues happening. Okay, so let's come back to the same scenario. PCA is sending some file to PCB. So the data or the Ethernet frame will hit this switch port. This switch port will now see two active switch port. Earlier it was only one. Now it see two. One is this, other one is here. Both are transmitting the same data. This is a default behavior of a switch. Broadcast. Okay, so what is broadcast? Whatever switch receives, it's going to forward from any number of active switch port. If there were more switch port, every switch port were carrying the same information. So let's say this data was carried over on that green cable, and the same copy of data is also getting carried on the red cable. Now they hit parallelly over here. Okay, now what happens is the switch, which is called as a broadcast device, it's going to broadcast one copy to this, second copy back to this cable. Similar way, the data or the packet which was received here, it's going to broadcast one to this and one back to this. Okay, the issue now is with those data that is getting circulated. Okay, the data which received here or data which received from other port over here, it's fine, they are doing their work. But the data which came to this, from there again it went back on the cable, again it reached here, again it was broadcasted to that as well as broadcasted to this. Now there is one layer which is causing the loop. Okay, so this is a example for a switching loop when your data is all over circulating. Now what is the issue if your data or your Ethernet frame is circulating? Okay, the issue arises because of increase in the MAC address table. Okay, now what is MAC address table? So let me tell you. these two switches has something inbuilt, okay, something called as MAC address table. What is MAC address table doing? It is binding all the physical switch port with MAC address of the device. Okay, or we can say source MAC address of the device. So let's say one copy of packet or Ethernet frame that was received here. So this entry will be saved inside MAC address table. So let me show you on a live box itself. Okay, so let's say this is my topology. If I open up 2 or 3 devices like this, so a MAC address table will be formed within switches. So this is my switch console, and if I see my MAC address table, okay, so this is the entry that is in my MAC address table. So the issue with the looping is we will see continuous flapping of the MAC address. Okay, the packet which is going to one interface, from there it's coming back on another interface. Everything will get flapping on this table. Now there is inconsistency in the MAC address table. You will see instead of 2 actual MAC address, there will be 100 or thousands of MAC address entering here. Okay, now this MAC address has its own memory. It has some threshold that it can save up to 50 to 100 of the MAC address. Okay, now when there are thousands of looping or thousands of duplicate entries, your original one, the real one, gets wiped out from the MAC address table. Now this is inconsistency. Now imagine during this looping, one of the actual or the original packet flow is happening. Now that will get wiped out, that will get dropped. Okay, and then you will see a lot of issues like slowness issue. You will see packet getting dropped. Okay, now this is all because of inconsistency happening in the MAC address table. Okay, if someone asks you what is spanning tree protocol, lot of guys say it's a looping happening in the switching technology, but how is it impacting the network? Okay, it is impacting the network because it is creating inconsistency in the MAC address table. All your original packet will take up a new bindings with the interface and get uh, inputted over here. Okay, so meanwhile what happens, your original packet or original interface that was supposed to be in this, it's gone, it's disappeared. Okay, so this is STP looping, this is spanning tree looping, and now this thing has to be avoided. So one best practice to avoid is by creating ether channel. Okay, I'll tell what is this ether channel in the next class. Just to answer that, let me tell you, ether channel is an concept. When I have 2 cables, I can bundle up them. So when I bundle it, it's equivalent to 1 only. Okay, the data will flow and data will incoming only on the 1 cable. Now let's say this is ether channel is used for distribution layer. Okay, we are talking about access layer and distribution layer. Okay, ether channel is again not used every here and then because of requirement of physical ports. Okay, so keeping in mind that I have only 2 STP ports, or I have two switches, 1 and 2, and I have two cables connected. So what is happening here is when I enable STP, one of the cable will be blocked. That is what your spanning tree is going to do. Now, why spanning tree is going to do? If let's say if I disable spanning tree, both will be active. If both are active, as I told you, it will lead to some looping. Okay, your packets will start rotating in this environment. Okay, your MAC address will start increasing, the MAC address of this switch will start increasing. There is inconsistency happening between the MAC address table. So what is the solution here? Solution is to introduce STP. How STP is going to help me? It is straight away going to block. Okay, it's straight away going to block one of the cable, one of the communication cable. That doesn't mean that unplugging or taking out the cable. Okay, the software within this devices will do some calculations and it will block this straight away. Now it's only one cable which is capable of in and out traffic. Okay, so this is all about STP. We need to see how STP makes the decision, what are the factors that is contributing for STP decision maker. Okay, well, so let's see what I have written. STP enables switches to become aware of other switches through BPDUs. Okay, now what is BPDU? Bridge Protocol Data Unit. What does BPDU refers to? Now let's say this is switch 1, this is switch 2. How is switch 1 coming to know that there exists one more switch next to it? Is it the cable? Cable is not going to do anything. Cable is just a connection between two devices. It's your BPDU. Okay, it's BPDU, Bridge Protocol Data Unit, which will be automatically sent. Okay, it will be automatically advertised. So this switch is going to send every other active port. So let's say I have a computer. Do you think computer will recognize BPDU? No, computer doesn't recognize any BPDU. Okay, so we will not be seeing any BPDU between a switch and a computer. The BPDU are only seen between two different switches. Okay, now what is the content of these BPDU? This we will discuss in today's class. Okay, I'm going to show you what is the content of BPDU, how this is going to help on STP, how the calculations happen, what are the algorithm. Okay, so that was the first topic. STP enables the switch to become aware of other switches with the help of this protocol, BPDU protocol. What is STP helping us? It's helping us to block one of the cable or redundant port. Okay, when I have two cables, I which can cause looping, I am going to straight away block. So that is what it says. It is going to block. It operates by specific switch as master switch and a based on tree structure. So let's say when I have multiple switches connected in this format. So how is your STP works is it will select one switch as a master switch, and we call that master switch as a root bridge, and rest all will act as a tree in the sense they will see how to get connected with the root bridge. Okay, so let's say this is a master switch and all others have to reach to this. So this is what is mentioned on the third point number. Okay, now let's check what are the different STP flavors that we have in industry. Okay, so this is one of the legacy STP method or protocol which is defined as 802.1d. It's also called as STP. This was announced in 1980s, way back. Okay, later on as the technology approached, like all our Ethernet mediums got advanced, like from Ethernet we went to fast Ethernet, from fast we went to giga Ethernet. So we also saw that there were a lot of timer constraint. Okay, there were some timers within this which used to take a lot of time. Now in industry, having lot of time for something to forward the packet is not good. Okay, that means let's say I have two Cisco switches connected. I have one computer, I have second computer. If one computer is sending something, now this switch will take 50 seconds for the port to release. Similar way, this switch will take 50 seconds the port to listen for the BPDU that is coming in, okay, or the packet that is coming in. Now this 50 second is equivalent to 1 minute, which is not good in the enterprise network, right? We wanted something advanced, so that was a drawback on this legacy STP. And then we had some Cisco proprietary like PVST plus, which is per VLAN spanning tree, per VLAN spanning tree plus. Okay, and also we had if open standard protocols like 8021W, which is called as rapid spanning tree, which is IEEE standard. That means it's a multi-vendor supported, not just in Cisco. These are two Ciscos, but this is multi-vendor. And also we have something which is called as multi-spanning tree protocol, and this is the IEEE standard. So the ones which are highlighted are the ones which is included in the CCNP enterprise. Okay, so today I'll cover up this, might be tomorrow this, and then MST in the next class. Okay, well, so let's see what else do we have. Okay, I'll talk about the STP calculations. Okay, how STP calculations are done. So take this as one of the Cisco switch, and let's take one of the Cisco switch as this. And similar way, I have one more Cisco switch. So all of them are connected in this way. Let's see. Let's write the MAC address of this switch. So let me write the MAC address of this switch as this. MAC address of this to be this. Okay, and similar way, MAC address of this to be this. Now I told you we need STP within a switching technology. If I don't enable STP, there could be looping happening. To avoid looping, I'll make use of STP. Now how STP works is, first thing what STP has to find out is root bridge. So among these three switches, who is going to get the root bridge privilege? Okay. So for finding out root bridge, there is a formula which is called as bridge ID equals to priority plus MAC address. Okay. Let's take priority to be a constant number, and let's take this is 32768. So this is a constant number on all the devices like 32768, 32768, 32768. So this doesn't get changed until we manually changes. Okay, if it is a brand new switches, by default they are going to be 32768 for every switches until or unless I change it or I increase it. Okay, so I'll tell you this manipulating this in the tuning part of STP, but as of now, remember this is a formula to find the root bridge. Okay, and always the lowest win, not the highest. It's the lowest that wins the election. So keeping into consideration that all priority are same, now the tiebreaker is your MAC address. So which one do you think is having the lowest MAC address? Okay, so these are in a hexa format, hexadecimal format. So let me tell you what is hexa and what is a decimal notation. Okay, let's say 1 2 3 4 5 6 7 8 9 10 11 12 and so on. Hexa, equivalent hexa is 0 1 2 till 9. It's going to be the same. Later on 10 becomes A, this becomes B, and C D E, so on. Okay, so as I told you, these are all hexadecimal. So if you see from this chart, this is 10, equivalent to 10. B is equivalent to 11, and then C is equivalent to 12. So this is considered to be the lowest. Okay, because it's equivalent to 10. Now let's say this is the second highest, I can say equivalent to 11. Okay, I can say second highest, and this is the highest one with equivalent to 12 value. Now as I told you, the formula says the lowest bridge ID will win the election. So priority is same. MAC address, the lowest is this. So my switch one will take the root bridge election, or it will win that election, and it will declare himself as a root bridge. So we are good with switch 1 now. So switch 1 says I am root bridge. Now it's switch 2 and switch 3 which has to make some decision. Okay, it will make the decision to reach switch 1. Okay, now what happens is, as soon as root bridge was elected, both its interface are going to get a state called designated port. Okay, designated port is nothing but which are always forwarding in nature. They are forwarding in nature. Now switch 2 and switch 3 will say that okay, let's find out the best way to reach switch 1, since they are directly connected. Okay, these both are directly connected. Now this one will take the role of root port. Okay, root port is also forwarding. It's also forwarding, it's also receiving. This is also root port. This is also forwarding, this is also receiving. Now issue is on this segment. Okay, so this segment, either it can go in this direction or it can also go in this direction. Similar way, this segment which can also be taken in that, also it can be taken in this direction to switch 1. Now one has to be blocked and one has to be designated. Now how do we see that? So the second step was to find the root port, which we have easily found out. Okay, the only thing to note for root port was the lowest cost to reach root bridge. Okay, so since there was no other switches, it was straight away, it was easy to find out root port. So sometimes finding out root port is also little difficult, but since this were a simple diagram, we could easily find out root port. Now the third and the last one is to find the blocking. Okay, now which one do you think would be blocking, whether this interface or whether this interface? Okay, so I'll just write once again. So let's say this is 1 2 3. Let's also assign some interface. Okay, so what is this? 0 1. Okay, so this is designated port. This is designated port, which is forwarding in nature. This is root port, which is also forwarding in nature. Now we need to find this and this, whether it's a designated or whether it's a blocking. Okay, so for blocking there are some criteria. The criteria says if the best or the lowest cost is not going to help me. Okay, now I have to see the lowest forwarding bridge ID, that is from this. If I consider in this direction, what is the bridge ID of this switch. Okay, so that is the criteria here, sending bridge ID. And we all know what is the formula for bridge ID, that is priority plus MAC address. Okay, so let's say priority is all 32768. MAC address of this was this. Okay, and when you have the MAC address this, so basically this is winning the election, right? So your traffic from this would be preferred rather than this. Okay, so in this particular diagram, if I just write once again in a proper way, so this becomes my root bridge. The whole switch becomes root bridge. Root bridge always have designated port. Okay, and opposite two switches, if I consider from this point and this point, they're directly connected. Okay, there is no block, or there is no chances of having any loop. And the definition for root port is lowest cost to reach root bridge. So this is lowest cost, right? So these two becomes root port. Now only the challenge is whether to this and this interface. Okay, one has to be blocking. Why one has to be blocking? Because the traffic or the packet can also take in this direction. Also packet can go in this direction, which will lead to circular looping. To avoid this circular behavior, we have to block that path. Okay, so which one is going to be blocked? It doesn't mean that you're blocking this, so you just can tell the interviewer that this whole thing is getting blocked. No, you have to say whether this interface is getting blocked or this is getting blocked. Okay, so that is the main thing here. So the criteria says, so let me just write it here, or write it down here. So once we have root bridge, I go and find out root port. Root port says that lowest cost to reach root bridge. Okay, now to find blocking interface. Okay, how do I find blocking interface? So I will see the least cost. If least cost is not going to help me, then it's going to be the lowest forwarding bridge, the switch. Okay, so in this case what happens is, it's basically this direction. This switch has the lowest bridge ID when compared to this switch. Okay, something which comes and go in this direction will face a higher bridge ID when compared with this direction. Okay, so this traffic is allowed, or we can say this is designated port, and this will be considered as blocking. Now let's say I have little weird design with me. So let's say I have one switch, I have one more switch kept like this, and I have two different switches kept in this this way, or this network diagram. Okay, so let's say this is root bridge. Okay, now second thing that I have to find is root port. So from this point of view, this is directly connected and it's going to be root port, and this is going to be designated port. Now out of these two switches, or out of okay, let me take these two as one switches. Okay, so let's say this is switch 3. When I have two different cables to my forwarding switch, so the third criteria is getting failed. That means this criteria is now not applicable, right? Because if you see from this switch, the forwarding switch is again same, right? So you cannot decide whether this to be blocked or whether this to be blocked, right? Because this is now not a eligible criteria. So for that, we also have one more That is the last tiebreaker, and we call it as neighbors physical interface ID or port ID, whatever. Okay. So what does that mean? So let's say if this switch has some port number. Okay. So let's say it has some port number FA0/1 and this is FA0/2. So what is the last one saying? The lowest sending port ID wins. So when you compare 01 with 02, it's basically this is lowest, right? So this becomes your forwarding in nature, and this one will be put up in the blocking state. Okay, so this becomes designated port. This becomes forwarding state. Okay, so let me write it as non-designated port, and this becomes blocking state. So this is how elections are being done in a switching technology, and these are few algorithms or these are few tiebreakers. For root bridge, it's always lowest. Okay, lowest bridge ID that wins. Root port are something which are directly phasing to the root bridge, so there should not be any confusion. The confusion always arises when you have to find out some blocking natures. You have to find which one to be blocked. Okay, so we will do that practical on this lab scenario also. These switches are all kept in shuffled way. Even I am not sure which is going to block, which is going to be root bridge, but we will do the lab. We will see some commands, we will trace it out, and then we will understand why this switch became root bridge, why this was blocked, why this happened, and then we will also try to manipulate. Okay, manipulate in the sense, let's say I have 8 switches in my lab. What if these two switches by default are elected as a root bridge, or let's say this becomes the first root bridge and this becomes the second root bridge. Now all of them have to point out to this root bridge. Now that is not a good idea, because you are always investing on a higher end switches that you keep on the distribution layer. Okay, so let's say these are the two switches which are higher level. You have invested lot of money. Rest of others are your normal switches, so you don't want them to take the root bridge eligibility. You don't want them to be root bridge. You always want it to be your first two switches. So we will see how to manipulate that behavior. Okay. Okay. So let me go back to this. Okay. And regarding whatever I discussed just now, the algorithms. So that is mentioned here for you guys. Okay. So you guys can refer this during interview. So there are 3 steps happening in the STP. One is finding out the root bridge. The formula says bridge ID equals to priority plus MAC address. And it's always lowest that wins. It's not always the highest. Okay. So priority by default is 32768 on all the switches until or unless you change it manually. So by default it is 32768. MAC address is something which you have to check on individual switches, and then you have to make the calculation why it took the root bridge, why how to change it. Okay, so the first step that happens in STP is root bridge. The second step is to find the root port. Root port is nothing but shortest path to reach the root bridge. Okay, so if I have a switch here and if I have 2 different switches, so basically the directly facing one becomes the root port. Okay, selecting the root port. The next criteria is to find the non-root bridge. So first thing you will see is cost. Okay, then you will see the lowest forwarding bridge ID. If that is a tie, then you will go with forwarding physical port number. So I have given you example of this. I have also given the example of this, and then you have the blocking port with you. So these are something which during interview they can ask you. So how is the question during interview? So basically your interviewer can ask you to draw one topology. Okay, so your interview says draw one topology with 3 switches in a triangular way. Okay, and explain us the STP process. Now you have to assume what is the MAC address of these, what is the priority of this, how elections happen, and finally which is going to be in the blocking, and yeah, all other things like root bridge and root port. So basically you have to decide. Okay, so in my case I said this is having the lowest MAC address. It's not required that you also take the same thing. You can also explain it by saying this is having the lowest MAC address and rest of them are to be calculated. Okay, so this is how the scenario is asked during interview. Fine, so let's see the other topics regarding STP port state. Now what is this? So I told you one of the drawback of STP is it take 50 seconds for a port to release. Okay, what does it mean? So let's say when I have my switches in a triangular way, we just discussed about root bridge, root port, and blocking. Now this is happening in a background. Okay, once this is happened, once this all these three steps have happened, then is your port which is going to forward the data. Until then, this port will be not forwarding anything. Now that is a drawback in your network design. The reason is, let's say you connect the switches but it takes 50 seconds every time to go through these steps to decide who is root bridge, who is root port. It is taking 50 seconds. Now that is not a uh, good thing in STP environment. Okay, that is why later on we had the RSTP, PVST coming in. Okay, so we will see later on what are the timers, all those things. But yes, what is happening in this 50 second? Is it only about these calculations? So along with this calculation, or in order to make it more simplified, we have some state. Okay, we call it as port state. These things happen within that state. So what are those state? Okay, so the first state says disable. This is a scenario when all the three switches are just connected but they are not enabled, or let's say all the switch port are admin down at the moment. They're all admin down. There is no BPDU sent. Okay, so you know what is BPDU. Every switches will send their BPDU to neighboring switches. So let's say disabled is a state when it's admin off. There is nothing going on. There is not even BPDU. The second step is blocking. Now this is the step when the BPDUs will be received. It can only receive the BPDU from other switch. It has not started sending, but yes, it has started receiving from others. So let's say this is a switch which is listening for others BPDU. Okay, so all three switches will listen for others BPDU. They are not sending it. Okay, so in this particular state, in a blocking state, your switches will rely for 20 seconds. So for first 20 second out of 50 second, the first 20 second is under blocking state. It's just waiting for others BPDU to come in. Okay, now it transit to second state. Now the second state is called as listening state. From blocking, after being in blocking for 20 seconds, it will get transited to listening state. So in this state, what happens is it can now send or receive BPDU. That means a switch can either receive or it can also send. Now in this state, it will be lying for 15 seconds. So for 15 seconds, your port will be on the listening state. And in what happens in that particular state is it will either send or it will either receive. And then it goes to learning state. So in the learning state, it will again rely for 15 seconds. And at this moment, what happens? It has received, it has sent. So it knows about all the BPDU of its neighbor. Now it can modify its MAC address. Okay, MAC address table. At this particular state, it's in a position to decide who will be root bridge, who will be root port and who will be blocking. So that is what it said, modifying the MAC address table. And once after that, it will get transited to the forwarding state. And the forwarding state is when all your network traffic, all your data traffic, all your voice traffic will start flowing across. Okay. So when you have switches in your network topology or in your office, for first 50 seconds they will not be forwarding anything. They will be doing their internal STP calculation. Okay. The states here are blocking, listening, learning, and forwarding. Every step, every state has their own functionality. Blocking is when it's not sending, but it's only listening for someone's BPDU. For 20 seconds, it's going to be in a blocking state. Then it goes to listening state, where it will be for 15 seconds. It will read, it will listen, it will also send the BPDU to others. Then it will go to learning state, where again it's going to be 15, where it will modify the MAC address table depending upon the algorithms that we discussed: root bridge, root port, and blocking, right? And finally it will go to forwarding. So this is a step, this is a state where your blocking will be decided. I mean, when let's say when forwarding is a state where it will know who is forwarding and who is blocking. So let's say from this switch point of view, after 50 seconds, this switch will know that this is decided to be forwarding, but this is decided to be blocking. So it took 50 seconds for a switch to go through all the state and to decide which will be forwarding, which will be blocking. Okay. So that was regards to the states of STP. Now regarding the terminology, okay, this I took from the console of a Cisco switch. I can directly show you on my Cisco switch itself. Okay. So let's take one of the console from the switch. So this is the console. What is the command to check show spanning tree attribute? So it's just show spanning tree. So when I input that command, I will see a lot of detailed information. Now someone who wants to quickly go back and review, I have given this even in the PDF so that you can refer back. Okay. Everything has been detailed, so that even after the class you can go back and you can go through this. So let me tell you what are these. So spanning tree enabled for VLAN 1. It's a IEEE standard 8021D, which is what it's shown here. Root ID is nothing but in this topology, in this network diagram. Okay. So in this network diagram, I have 3 switches, 1, 2, and 3. Okay. Forget the others because I have not powered on them. So until I power on, they are not contributing for any STP. They are down as of now. So at this moment, only these 3 are powered on. Okay. The green ones. So out of these 3, one has taken up the root bridge. Okay. So I'm not sure which one has taken up the root bridge, but if I see from the console, I can make sure that this is not a root bridge. Okay. Why do I say this is not a root bridge? Let me show you. So if I open up all the 3 consoles, okay, this is also a not root bridge. Let's see this one. Okay, this is the root bridge. Why? Because we can see something labeled. This bridge is the root. So basically, out of these three switches which are powered on at this moment, this one has taken the root bridge. Okay, so we will see why it has taken, but before that, let's see the different values that is shown up in the spanning tree table. We also have some detailed information about hello timer, max age, and forward. Now, what is that? Hello time is nothing but every 2 seconds is your BPDU sent. Okay. Now there are 2 types of BPDU. One is called as configuration BPDU and second one is called TCN, that is topology change BPDU. Now what is the difference? When I'm configuring STP or when I'm power on some switches for the first time, that is this configuration type of BPDU that is taking all the details like MAC address, priority, and then the calculations are happening, and then which is forwarding, which is blocking is being decided. Okay. Now let's say that is done. Every switches are powered on. They have done the root bridge election, all those things. Now, one fine day, there was some switch which went down. Now there was that particular changes is something called as topology change. Okay. Now during that time, this BPDU is going to take that responsibility of reconverging. Okay. Reconverging in the sense, let's say these are the three switches at this moment. Now it was all your configuration BPDU which has taken care of election, all root bridges, blocking, all those things. One fine day, this switch went down. The root bridge itself went down. Now there will be reconverging, right? Among this two, one has to decide which is going to be the new root bridge. Now that time is your TCN type of BPDU coming into picture. Okay, I said there are two types of BPDU: configuration and topology change. So the second one is topology change of BPDU. Okay, so as of now, this is your BPDU, which is for every 2 seconds. Every 2 seconds, the BPDU will be sent on all the direction. All the switches are sending the BPDU to make sure that devices are up or down, and if there was any changes, so that recalculation will happen. Okay. What is max age? Let's say this went down. This is a root bridge and it went down. It will wait for 20 seconds for the switch to respond back. If the switch will not respond back, the reconvergence will happen. Forward delay, as I told you, there are states, okay, the port states of STP: blocking, listening, learning, and forwarding. So what is the forward delay? From learning to forwarding, how much seconds did it take? It took 15 seconds. So that is the delay which is mentioned here. Now there are two values here. One is called as root ID, one is called bridge ID. So basically root ID you can see on all the switches, that will be unique. Okay. So as of now, this is root bridge. So the value of this will be inside the root ID of this. How can I validate that? So let's say, so, and what is bridge ID? This is the local switch information. Okay. So under spanning tree, we will be seeing two detailed value. One is root ID, one is bridge ID. Root ID for all the three switches has to be same. And which one is that? It's for the root. Okay. And bridge ID on all the three will be its own local information. Okay. I can prove that. So let's say this is a bridge ID for this particular switch, which is now acting as a bridge. What is the MAC address? What is the address? It's, let's say it is 9400. So this address is also taken up here. Now if I talk about other two switches, so do we see the same MAC address over here? Do we see the MAC address of the third switch also on switch number 2? Also this MAC address will be on switch number 1. So what does it prove? When we are in a STP landscape, the root bridge detail will be stored on all other switches also, and especially under root ID. Root ID is nothing but detailed about the root bridge. Okay. And the next one, that is bridge ID, is local to its own switches. So that is different. So let's say the first switch had this, the second switch will have its own MAC address, and the third one will have its own MAC address. Okay. So only the thing that we see something getting shared is the root ID detail, and especially the root bridge, the switch which is root bridge, the detail will be getting stored in this way. Now let's say if you landed up on one of the switch, you just landed up on one switch randomly. Okay, you didn't know that it's a root bridge or it's non-root bridge. So from this, we can, yes, make sure that this is not a root bridge, because if it was a root bridge, we would have expected something like this. Now we don't have that here. And it is showing me the root or the MAC address of that root ID. Okay, now I can trace this and I can find out, I can come to this. So this is my root bridge and all others are following myself. Okay. What else can I see in the MAC address table? I can see the interfaces. Okay, so on this switch, I have these many interfaces. They're all designated port. That is what I told you. The root bridge will have all its port in a designated way. So I said if I have 3 switches, this is a root bridge, it will have all designated port. Designated port are nothing but forwarding in nature. You will not see even one single blocking in nature. Okay, so that was one thing. Second, what are these cost value? Okay, these are nothing but these are the cost that is between these two interface. I'll tell you how these numbers we got. Okay, so these are the cost value between each one of them. What is priority and what is number ID? So do you remember the last this the most the last one, that is this criteria, the fourth criteria. I said that if in this scenario, especially while discussing about this scenario, this particular tiebreaker was not effective. Lowest forwarding bridge ID was not effective. So I said we will go with neighbor's physical interface ID. Now, how would we calculate that? How would we know that? So basically, we would know because it's been labeled here. Okay, 120 is standard priority for every interfaces, and 1, 2, 3 is being arrived from this. Every interface has given something. So this is how I was able to find out in this network design. I told you the one with lowest port ID will forward, the one with highest will be blocking. So here I can easily find out 128.1 is lower than 128.2. So basically if this is 128.1, this is 128.2. So basically this will win the election and this will be blocking in nature. And P2P is a medium. Okay, we will see a lot of medium here. Like this is point to point. We can see some. We can also see some shared medium. So that's basically upon the network design types. Okay, so as of now they are all point to point. So this is a complete overview of spanning tree. Okay, so what else? So basically same thing I have mentioned here. Yes, if you have noticed something, as of now they are in a learning state, but what I showed you was in a forwarding state, right? So that is something we will do in lab and we will see then. Okay, so let me cover few things and then I'll show you. So these are the port states. This is the show spanning tree output. Okay, the root bridge, BPDU. Okay, some key terms. Okay, some key terminology of STP. Root bridge, you all know that the one with lowest priority plus MAC address will win the election. So that becomes the root bridge. What is BPDU? BPDU is something which will carry the advertisement from the switches. Okay, so every switches, as soon as you connect them, as soon as you enable the switch port, they will start transmitting BPDU. So every 2 seconds, the BPDU will be exchanged. Okay, and in the case of STP, this is the MAC address that your BPDU is using for. Okay, so let's say these two switches, as soon as you enable the switch port, the STP BPDUs are being sent. Okay, so let's take this is going over on this. So on this destination switch, this is the MAC address that's listening for incoming STP BPDU. Okay, so it's this way. I can also show this when I'll do the lab. I'll open up Wireshark and I'll show you what is the destination MAC address for which the BPDUs are listening on. Okay, so this is a MAC address. It will be listening for the incoming BPDUs. As I told you, there are two types of BPDUs: configuration BPDU and TCN. Configuration is one which deals with your basic, the initial basic things like STP type, root cost, the local bridge identifier, hello timer, all those things. What is TCN? Whenever in future there is some uh, topology change, if you add one extra switch or if you remove one extra switch, there will be some updated packets, right? So that is taken care by TCN packets. Now what is root path cost? Okay, so from once you have root bridge, the next thing that you find is root port, right? How is root port been considered or selected? It's your shortest path to reach root bridge. Okay, so that cost is root path cost. What is system priority? I told you it's 32768. Always it's 32768 until or unless we modify this. Where is this getting used? On our bridge ID formula. Priority plus MAC address. And where is this formula used? It is used in root bridge calculation. The first calculation. Okay, so this is the value. It's a 4-bit component which has 32768. So we can change it manually, but not automatically. By default, any switch that you power on, it's going to be 32768. What is system ID extension? So this is a component which gets added up to this. Okay, and what is that going to get added is your VLAN number. So let's say I have VLAN number 1. So I will add 1 and this becomes 32769. If I have VLAN number 10, then it would become 32778. So no one asked me about this. So let me go back to the console and let me show you where do we see this. Okay. If I take up this table, so this is where we saw this. Okay. So if you see this, in spite I telling the default priority is 32768, but this is 32769. I was expecting someone would have asked me, or maybe you guys already know this because this is a CCNA topic, also CCNP repetition. Okay, so let me just iterate this to you. How we got 32769 is we just added up 1. Why do I add 1? Because 1 is my VLAN that I'm considering. Okay, so if you see this formula, this box, so it's basically 32768 plus 1. 1 is nothing but your VLAN 1. Now if this was a VLAN 50, so you should have added 50 to this, and then your new priority becomes 32 whatever the next value is. Okay, so that is why if you ever see something other than 32768, don't be surprised. It's because you're adding up VLAN number. Okay, so that is important thing which even interview asks to confuse you. Okay, so that is what this says. Root bridge identifier is nothing but it's a combination of MAC address, system ID, system priority. So do we see that? Where do we see that? We see that over here, root identifier. Okay, the information of the root bridge switch. It's a combination of priority, MAC address, cost, port number, hello timer. So something which is written. What is local bridge identifier? It's also called as bridge identifier. That is this value. Okay, the local information of the switch. As I told you, max age is nothing but hold timer. The BPDUs will be sent every 2 seconds. If consecutively all 10 get lapsed or expired, if there is no response back, it will declare it the other switch as dead, and then reconvergence happen. The new election will happen with the new switches. Okay, we can change that behavior from 20 seconds. I can change to some smaller value, or I can also go with some higher value. Okay, so as of default, it's always 20 seconds. Now, if to change that, what you just need to do is you need to go to the configuration mode, spanning tree, VLAN, the VLAN number is 1, go with max age and then change the behavior. Okay, so you can set anything between 6 to 40. As of now, it is 20. You can just change it. Okay, But if you change this, make sure you change on every switches. Otherwise, there will be inconsistency between the switches parameters. Okay. Hello timer. Hello time is nothing but the BPDU advertisement. So it's by default 2 seconds. Forward delay. I told you there are states, right? What are the port states? Blocking, listening, learning, and forwarding. So from learning to forwarding, it is taking 15 seconds. So that is the delay, which is mentioned here on my this one under my show spanning tree protocol. Okay, so that was some key terms. Now this is a BPDU. Okay. Now I'm not sure whether you guys have already checked this, because I know some of you are already CCI, might be some are have CCNP certification as well. So this is a BPDU message, okay, which is in your data or in your Ethernet frame. So inside your Ethernet frame, the STP packet, the payload, okay, it will contain the BPDU, which will carry all the information from one switch to another switch. Also, it will expect the information coming from a different switch to itself, so that they can calculate what is what, right? So I was talking about root bridge. Saying that a switch with lowest priority plus MAC address will win the election. But now, how is your first switch going to know that who is having the lowest one? So let's talk about this diagram. I said this is going to win the election. But how is switch 2 and switch 3 going to know that it's switch 1 who is having the lowest information, the lowest value? That's something from BPDU. So that means BPDU is carrying all the information. So under BPDU, there is something called as bridge ID, which consists of 8 bytes. So this is a parameter which is taken up. Now the formula for bridge ID is priority plus MAC address, okay, which is a part of your BPDU component. Now when BPDU are transmitted, this is also within that, and that is how the calculation happens, and then they go towards the transition states, and then they decide who is root bridge, who is root port, what is what. Okay, so the information, all the information will be taken up within the BPDU. This is a main important component for the STP or any switching. Okay, this is the switch. This is a component which will be seen between the two switches. Okay, BPDU will be not seen between a switch and a computer. Computer is a non-BPDU device. Okay, now what else can we see? It's your protocol ID. For STP, there is some protocol ID which will be stored here, because there can be many other protocol also, like VTP, DTP, what else, UDLD, right? One among them is STP. For STP, to say that this payload or this data is for STP, there will be some identification number. So for STP, it will be something like this. Okay, so that represent, it's a 802.1D. It's a STP representation. It will have protocol version ID, basically on which STP protocol version ID it's running. So it's again something like this. Okay, it's going to have BPDU type. I said there are two BPDU type. One is configuration BPDU and one is TCN BPDU. It's going to contain flags. What is flag? Which consists of 1 bytes. Okay, now let me tell you what is byte and bit. Okay, 1 byte equals to 8 bit. So this table consists in byte unit, and whatever I have written is in bit unit. So don't get confused. Okay, if I'm talking about flag 1 byte, that is equivalent to 8 bit. Now this indicate the purpose of BPDU, whether it's a acknowledgement or whether it's a topology change. Okay, now when we have TCN, now there are two different purpose of TCN. One could be the actual topology change notification. Once the notification is been sent, the other switch has to send the receipt, right, that it has acknowledged or it has received it. Now that is acknowledgement packet. So that is why flag is within this BPDU, which will say whether this is for acknowledgement or whether this is for the topology change packet. Then we have root ID. As you know, root ID is the information of the root bridge, like the priority, MAC address, timers, all those things will be placed. Then you have root port path cost. The path cost is of all the interfaces. Okay, so these interfaces will have some cost. As good as telling someone boarding a metro train, and if he wants to travel from A to B, he has to pay some of ticket fare, right? So everything, even your STP, follow the same thing. If something has to travel from here to here, there is some standard cost for this. Now this cost will change depending upon the Ethernet or the cable medium. We know that the oldest one was Ethernet cables, which was launched in 1980s, which was able to support 1 Mbps of speed. Later on, we came with fast Ethernet, which was able to carry 100 Mbps of speed. Nowadays, we see all your Giga Ethernet, 10 Giga Ethernet, which is capable of 1 gigabits per second. So even the spanning tree is changed. The cost value of spanning tree is also changed. For, let's say, the spanning tree cost is 100 here. This will get changed to 19 here. Let's say this will change to this. So the more advancement is happening, the cost is also getting decreased. Okay, so that value is also within the BPDU packet. Bridge ID is the local information. Port ID is your 128.1, 128.2, which I just showed in the spanning address table. Okay, message age, max age, hello timer, forward delay. These are some information about the messages. Okay, so let's say the BPDU message, for how long this BPDU was revolving on that network, the age of the BPDU, the age of the configuration BPDU. Max age is the hold timer. Okay, the maximum hold timer that your spanning tree table is going to keep the other switch. If after 20 seconds there is no response, it's going to remove that and the reconvergence will happen. Then we have hello timer. Hello timer is nothing but every 2 seconds the BPDU get transmitted. Forward delay is from forwarding, from listening to forwarding. Delay is called as forward delay. Okay, this is the diagram of BPDU in much more easier way. Okay, which I have tried to explain on this step by step. We covered port type. This is just the written notes. We have root port, we have designated port, we have blocking ports. Port election, we already done that. Okay, regarding the cost. Okay, most of you guys may not be knowing this. Okay, if you know, then it's good. If you doesn't know, then let me tell you something. If you quickly go back to the BPDU, if you see this, the cost has 32-bit dedicated, right? But earlier we had only 16-bit assigned here. Now with the advancement of the Ethernet technologies, we have extended this to 32. Same as your cost also have been changed. So what is the changes that we see in the STP cost? So like I said, initially or originally it used to be 16-bit, which used to be referenced to 20 gigabit per second. But now since the advancement happened, since we have faster links like Giga Ethernet, we saw some limitation. The limitation somewhere happening at this part. Okay, if you just observe, after 2 or after 10 gigabits per second, it's going to be the same value for all other mediums. Like your 20 gig is also going to get 1, your 100 gig 1 tetrabits per second is also going to be 1, and so on. Now this is a limitation of your traditional or your older formulae or the calculation. So that is why we are making use of the long mode method. So there are two cost mode. One is called as short mode and long mode. So this one is being carried by the 32 bit inside your BPDU, whereas this has been taken care by 16 bit in your BPDU. And the reference for this calculation is 20 gig bits per second, and this is 20, I think this is called as 10 or tetrabits per second. Okay. This concept we also see in OSPF. In OSPF, we have a topic called auto cost summarization, right? So under auto cost summarization, we have some legacy method of formulae, and we also have some latest or the advanced formulae. Okay, and yes, if you see this cost, show spanning tree, if you see this cost over here, or if you see these cost mentioned here or here, that doesn't that directly refers to this interface. Okay, so STP cost 4, that means link speed is 1 gigabits per second. So is it true? So let's validate that. Okay, the quick way to check is by this command. So let's say show spanning tree. Let me take one of the interface. Okay, so that interface is having cost value of 4. So let me find out what is the speed of that interface. So let's see what is the speed. The speed is this. I am going to take the whole value. I'll paste it here, and let's convert to gig bits per second. So that refers to 1 gig per second. So is it true? Right? So that is the right one, right? So that is why I got the cost value of 4, because my switch is supporting 1 gig gig bits per second technology. That is why the cost is 4. Okay, so this is regards to cost. All you have to remember is the short mode. As far as I remember, I have never seen anyone asking the long mode because of uh, the values. Okay, yes, they can ask you, but I would say that remember these values. They can give you, or they can ask you what is the cost value for 10 mbps or 100 mbps, and then you have to just say it's 100, it's 19. So just remember 100, 19, 4, 2, 1. It will be pretty easier. Okay, so that was regards to the cost value, the two things. Yeah, how do we change the, so by default your switches are in this mode, but how do we change this? So just a single command. If I go to the switch, go to configuration mode, spanning tree, path cost, method. Now there are two ways. Okay, by default it is short, but yes, you can make it to the long method. But only thing to remember is you have to change this throughout your network design. All the switches in that case have to follow the long. Otherwise, there will be inconsistency. One will be giving you 4 cost, one might be giving some other cost. So just keep the same thing by default across the whole network diagram. Okay. Fine, the rapid spanning tree I'm not going to cover today. I'll take up to the lab. But before that, I would like to ask or take the Q&A from you guys. Okay, so if you have any theoretical doubts, so let me know. So any questions? Okay, so there are a few questions put up here. Okay, regarding that lab, it was just a weekend. I just thought might be, since we all are in a lockdown phase, might be you guys would be free, and you don't have to do, because that is a part of class. I will of course take those class. I might be in the next following classes. Just it was given as a practice. If you want, you can. Okay. Okay, which how can we troubleshoot which port is flooding? So basically, I know why when you asked this question. So this question was put up when I said when I have a looping happening, okay, due to the inconsistency, what is happening? The MAC address table of these devices are getting piled up. Now, when the MAC address are getting piled up, you will also see that the CPU of every devices are getting choked up. Okay, the high latency is happening. Now, whatever data you send to those devices, they will start dropping because there is no enough resources for the switch to switch the packet. It is already overconsumed. Now it doesn't have any resource left to switch. Okay. So how do you make which is flapping or which is flooding is your switch. It will be not limited to just single interface. It will be now a global issue on your switch. If you open up your Cisco switch, if it is encountering these looping, you can see under the logs, you will see uh, log saying that this switch, let's say Cisco 3750, is having this many MAC address which is not eligible or that is beyond the threshold of this particular switch model. And if you keep on getting these logs, that says that you have been hit by switching loops. So this is one way. Second way, if you open up your show MAC address table, you will see hundreds or thousands of MAC address which is causing you the flaps. Okay, so these are the some ways where you can uh, troubleshoot. But how do you come to know that there is switching loops? It's your slowness. If one fine day one of the application team or one of the server team comes to you network team saying that my application is loading very slow, or if my software is very slow, so basically you will start doing your L2 troubleshooting. From interface point of view, you will start troubleshooting, and that is where you will land to one of the device, and you will see that MAC address table is beyond threshold. You keep on getting the log saying that duplicate MAC address found, or this hardware is running on its maximum threshold. And then that is where you will realize that there is a looping happening. Now you have to cut down the flow. Okay, cut down the flow in the sense, let's say you have multiple end devices which is on 10, 20, and 30. Okay, and let's say you already had multiple users. So what you can do is you can take few of the users from this by admin shut down these and just migrate to some other. So what happens is gradually your MAC address will also start reducing. Okay, and you have to find the culprit. It might be there might be some ethernet cable which is connected back, or might be there is some looping happening. You have to find the culprit, shut that, and then you can also bring this different VMs, different users on different switches rather than keeping on one. Some people, what they do is, like, in case if you're already ready with the latest technology, from STP you can move to the fabric path. Okay, now this is a Nexus technology, but that is what I said. If you're ready with the next technology in your data center, you can bring this STP users into the Nexus. Now in Nexus or in Fabric, we don't have STP. Okay, so this Fabric path is a latest technology which works on IS protocol. It doesn't work on STP. So this is a turnaround, or this is the solution for and to solve this kind of looping issues. Okay, so yes, there are multiple ways you can solve this, but first thing is finding out the culprit, okay, and cutting down first that, and then yes, you have to proceed. Uh, okay, so yeah, switch 3 will be blocked. Okay. Okay, so for this, I have the lab topology, which I'll show in few minutes. So what is SHR? Okay, so I know what you saw. So basically you are referring to this diagram and you are asking what is this. Okay, so basically this is nothing but this is a shared medium. You can see multiple different types like P2P, which is point to point shared medium. It's about how you have designed your network. Okay, so in my case, since these are all directly connected, I was getting point to point type of STP. Oops, okay. Okay, see, first when STP is configured, it's BPDU, okay, not CPDU. BPDU is exchanging, yes. It's not about only STP. When you power on two switches, STP is one factor in that. Along with STP, there are many other switching protocol like DTP, UDL. I'll just show it, okay? I'll just show that. Don't worry. Okay. Okay. I just realized that whatever I show on my Zoom chat is not visible to you guys. So, are you able to see the chat window at this moment?
Yes.
Oh, okay. Oh, okay, great. Because I was testing this with Abdul. Okay, so basically we found that when I show my chat window, it's not visible. So I was wondering whether you guys can see or I'm keep on answering something which you guys are not able to. So okay, good to know that you guys can see this. Okay, yeah, regarding the system extension ID, it's adding of that VLAN number. So in my case, it was VLAN 1. So that was getting added to the priority value. That is why it became 32769. 32769. By default, it's 32768. But since I added up 1 because of that sys external ID, it added up. Okay. CRC error, cyclic redundancy circle, or what you call CRC. Okay, this is one kind of error. Okay, so when I open up,
Check.
yeah, check, yeah, great. So when I check this interface, show interface 0 slash. So if you see, there are multiple factors for the packets to drop, and then they get assigned to each one of them, like drops, you have CRC, you have input error. Okay, so the usual reason for CRC is your physical interface issues that deals with either SFP module or your cable connection. Okay, so this is something which we do when we see CRC issue. So even in your case, if you see CRC increasing, you can ask your field engineer to either replace SFP or cables and then give a test. Okay, so it's a physical layer issue. What else? What is relation between BPDU and power in line? So where is this power in line? Did we talk about power in line today? Or do you mean to say uh, power over Ethernet? I hope you are. Okay, so I'm not sure where you got this. Okay. Port fast we have not covered, but yeah, let me tell you, this is one feature where we disable all the different states. Okay, states in the sense, as you know that STP is taking 50 seconds from blocking to listening, learning, and finally reaching to forwarding. It is taking 50 seconds. Now let me ask you one question. When I have a switch connecting to some computers, which is a non-BPDU device, so why do you think I should wait for 50 seconds? Right? I don't have to wait for 50 seconds because there is no way there will be some looping happening. Looping is happening between two BPDU sending devices. Okay, when I have two switches, there is a chances I have BPDU. I have some looping, but looping will not occur between a switch and a computer. So in this case, I would like to reduce this 50 second to some very shorter duration, because whenever I connect a computer, if it takes 50 seconds, then let's say if I'm testing out some features on the computer, and if it is taking every time 50 seconds, then that is impacting my production time. So what I can do is I can enable the port fast feature. Now when I enable port fast feature, all the other states are getting disabled. It's straight away from learning will get transited to the forwarding. So it will take your 15 seconds for the transition, and your port is ready for forwarding the packet. So we will do some labs for port fast. Okay, fine. So I guess there is no further Q&A as of now. So let me quickly go to the lab, and let's wind up this spanning tree protocol. Okay, so your lab document is updated. I have updated few more things, so I'll give you after the class. Okay, BTP and yeah, STP. Just a second, guys. Let me put on charge. I'm just placing on mute for just a second. Yeah, I'm just back. Okay, so this is the lab PDF, or the lab document. So what I have to do is I have to power on a couple of the switches. So let me power on these 8 switches, which will be used for practicing switching. So what happens is, as soon as I have powered all 8, all 8 will start sending or transmitting the BPDUs, and then one of the best, or the one which have the lowest bridge ID, will become the root bridge. Okay, so we can see the BPDU getting exchanged with the help of Wireshark. So this is a Wireshark. Okay, what is Wireshark basically is, it's a packet sniffing tool. So what it does is, whatever packet is being taken out or coming into a switch can be seen across on the Wireshark. Okay, the switches are still coming up. Okay, and as soon as switch comes up, we can see the BPDU started exchanging. And now what are all contributing to BPDU? BPDU doesn't only carry STP. STP is one uh, part in BPDU. Okay, so let me tell you what is happening. Okay, so as soon as switches come live, they start exchanging BPDU. Now don't think BPDU is STP. Okay, there will be multiple STP getting transmitted. Now inside that BPDU, one component will be for STP, one might be for other BPDU. The component will be given to some other protocol like DTP, CDP, STP. Okay, so just let me tell you, let's say this is BPDU, which is this okay, which we discussed all each component. At the end, I also discussed about something like payload. Payload is nothing but the data. So this differs every time. Let's say the first BPDU was carried for CDP, Cisco Discovery Protocol. One protocol was sent with the help of BPDU. Now the second BPDU was sent for DTP, Dynamic Trunking Protocol. Okay, now CDP will be taken down and the DTP will be sent. Now let's say the third BPDU was not for CDP, not for DDP, it was for STP. Okay, and we are focusing at this moment for only STP. Okay, in the later on classes we will see about DTP, CDP, all those things, but as of now we are focusing only on STP. So what I'm going to do is, instead of having these many protocols, I'll focus on only STP packets. So this is how I'm going to filter it out. Now I see only STP packets. If I just elaborate them, this is my physical layer information. So we all know what is OSI layer. Okay, what is OSI layer? Physical layer, data link layer, network layer, session layer. What else? Presentation. Okay, we have transportation, which I missed. Session, presentation, and application. Totally 7 layers. Okay, so the first 3 layers are called as a software layers, and the next 4 are called as a network, or the hardware layers. Okay, software is nothing but all it deals with these ones. Okay, the internet browsers. So basically whatever I am typing here, whatever is taking to the internet via the get HTTP or the HTTP transport layer, they all contribute to the software layers. Then we have the hardware layer where we have transport, network, data, and physical, and these 4 layers can be checked on Wireshark. So if you see this, we have 4 information. So this is for physical, this is for the data link layer. Okay, and this is, since I don't have any routing here, so I don't see anything for network layer. Okay, and I see directly the data packets. So if I elaborate these things, I will see what is inside them. Okay, so this is about the all your cabled or physical layer, which we don't deal with. This is a Ethernet header, which is a data link layer. And if you remember, I was talking about spanning tree destination MAC address, right? See, the spanning tree destination MAC address is always this. So what does this mean? When I have 2 switches, when my BPDU, the BPDU with STP, I'm not talking about BPDU with CDP or DTP. I'm talking about BPDU with STP. Now let's say this is getting transmitted from A to B. So on B, switch number B, this MAC address is keep on listening for the incoming BPDUs. Okay, so the MAC address will be over here. Let's say 0180C2000000. Now this BPDU STP will go and hit on this, because once you're sending something on other side, there should be some receiving point also, right? If there is no receiving point, then how are they going to send successfully? Then basically then this switch has to drop that, right? So there will be something listening, that is this. Okay, this is the listening MAC address for STP. Okay, we are discussing about STP. So when BPDU is carrying this STP, this on the other side, this is the MAC address which is listening that. Source is nothing but this, whatever you see here, the source MAC address. This is the MAC address of your switch A, the MAC address of this port. It doesn't matter what is the MAC address of this. It could be for GI 0/1, it could be for GI /0, it could be for GI /2. So it doesn't matter. It only matters is on the receiving side, there will be some STP MAC address predefined. Okay, every time on a receiving side, this is a MAC address which is where you have to send the BPDU for STP. Link logical control, this is the 2 layers within data link layer. Okay, if you know, we have a data link layer, right? Data link layer, which consists of 2 things. One is MAC address and one is logical link, LLC. So MAC address is nothing but we have over here this 48 bits. This is a 48 bits MAC address. What is MAC address, by the way? MAC address is the physical identifier number of any IP capable devices. It can be on your laptop, your computer, your mobile, iPad, tablet, no matter what it is. If your device is capable of IP, it will have some MAC address. Okay, it's a unique identification number, and each MAC address have its what you say. There's some way of notating or notation for a MAC address. We will see this in future classes. Let's not deviate from STP now. Okay, so this is MAC address and LLC. LLC is one of the sub-segment of data link layer, and this is the payload. Payload is nothing but the actual data the packet is taking. Now, what is it going to carry? So it is going to carry spanning tree protocol, which is in the hexadecimal format 0x0000. Now, if you remember, I have already disclosed about this information. So if you go back to this PDF, I was talking about some key terminology. Okay, is it key terminology? Okay, it was this BPDU. So where I said protocol ID for STP is always 0x000. Basically, this is a hexadecimal. So you know what is binary. Binary is nothing but 0 and 1. You know what is decimal. 0 to 1, 2, 3, 4, 5, 10, 11, 12, 13. That is decimal. And you know what is hexadecimal. Okay. So this is a STP indication in a hexa format. So that is what we are also seeing in a practical approach. Okay. This is a protocol identifier, hexadecimal. This is the protocol version identifier for STP, which is what I also have mentioned here. It's this. We have BPDU type. Now this is a configuration BPDU. Okay. We are discussing about all the states like blocking, listening, learning, and forwarding. So these are responsible with the help of configuration BPDU. When is your topology change BPDU coming in? It's coming on later on when everything is set up, and if one switch has been added up, if one switches is taken down, now there will be topology change notification sent saying that switch 3 has been taken down. Now let's reconvergence or recalculate the root bridge, root port, etc. Right? So at this moment, it's a configuration BPDU. We have BPDU flags. I said BPDU flags are used especially for topology change kind of BPDUs. Okay. So in that case, one will be to take the TCN packet. Second one is to acknowledge that packet, saying that yes, I have received the topology change notification. So accordingly, this value will change. As of now, it's a configuration BPDU, so we don't need anything there. We have root identifier. We know what is root identifier. It's basically the information of a root port, a root bridge switch, like the priority of the root bridge, like a MAC address of that, and all other details. So you can see this. This is the priority VLAN and the MAC address of the root bridge. We have root port path cost. Depending upon Ethernet, fast Ethernet, Giga Ethernet, the value gets saved here. So it's saying 4. That's because we are making use of 1 gigabits per second of interface. That is GI. Okay. So something like this. That is why the cost shown is 4 here. What else? We have bridge identifier. Bridge identifier is local to each switches. So this detail is for this particular switches. We have port identifier, which is in hexadecimal format. Port identifier is nothing but this value. So let me show you directly on the switch. Okay, this is port identifier, port numbers. We have message age, max age, hello time, forward delay, which is again we discussed already. Okay, the hold timer, the time interval for all BPDUs. The forward delay is nothing but from listening, from learning to forwarding state. Okay, so this is something which we just saw from the BPDU point of view. When the two switches were powered on. So once they powered on, they were having all the required information, bridge ID, all those things. And I'm very sure that they have done their intelligence work. Switches are very intelligent. Okay. We don't have to write routing in this. Unlike in a router, we have to specify everything, then router routes the packet. In case of switching, we don't have to do anything. It will do its calculation, and it is very intelligent when compared to a router. Okay. So it has done everything. I am very sure that it has done everything. I can straight away go and see, start looking for the root bridge. So like I said, in my earlier case, when I had only 3 devices, this one was elected as a root bridge. But now when I have all the 8 switches, I may not know, might be someone else have taken the root bridge election, right? So we can check that. Let's see, how do we check that? Okay. So if I go to console, so if I see on the first device, let's show spanning. This is not a root bridge. Okay. And from my diagram, I cannot make sure which is root bridge, because I have not mentioned any MAC table, right? So that is what I also have mentioned on my workbook. So how do we find which is root bridge? So what you have to do is you have to find the output of root spanning tree on all the switches. Okay. There is no shortcut here. Until someone gives you MAC address, you just cannot find. You have to trace it down. So I'll randomly go through one by one. Okay. So let's see where I lead to, or where does it lead to. So let's say show spanning tree. This is not the one. Let's check out on the 6th switch, show spanning. Okay. So this is also not the one. Okay, so as of now, the switch number 5, this switch has become the root bridge. Okay, even though we had a very good switches which is kept in the core distribution layer, one of our access switch becomes the root bridge. Now that became root bridge because of the bridge ID criteria. Bridge ID priority plus what do you have, MAC address. Okay, since priority is same everywhere, it's 32768. Now MAC address of this was smallest when compared to other things. That is why this particular switch grabbed the role of root bridge. And if we just double check, we can see on all other switches it will be pointing to this MAC address. Okay, so the root ID of other switches will be pointed to this BE00. Okay, so let's check. So if you see this BE00, that's nothing but it's a MAC address of this switch. Show spanning tree from second switch. This is also started pointing to your switch number 5. Okay. Now it's all good. We know it did its calculation. There were 50 seconds of hold time for the transition, all those things. And along with that, what I want to do is I want to change the default behavior, and I want these 2 switches to be my primary. Okay, so that is all this lab about. The lab is not just to go trace the root bridge. That it has done the work. What is my contribution to this as a network engineer, right? Now my contribution is to change the behavior. I want my switch 1. Now if you think that why don't we disconnect this and place here, then that is not the practical things. Okay, that we can disconnect this and we can connect here, so that automatically the reason is, as I told you, this is a lower end switch and this is a higher end switch. So by replacing will not solve my issue. I have to manually do that. Okay, first, before doing anything, I want to show you the transition period. Okay, so let me follow the lab notes so that it's easier. So the first step, or the task number 1, is completed. We know what is uh, the root bridge. Okay, and I have also mentioned on what basis the root bridge was selected. So in my case, this was the root bridge. But yes, since this lab is being put up on every student's laptop, I'm not sure whether you will also see the same behavior. The chances are that you might get the same behavior, that this get elected, since we just copy pasted or replicated the lab. Otherwise, just be aware that the root bridge is something which is elected on basis of this MAC address. Okay, so now I have to change the behavior. I what is my behavior? So let's say I want my switch number 1 and switch number 2 to be the root bridge. Okay, and what are the commands to do that? So there are two ways I can change the behavior. One, either change the priority. I cannot change the MAC address. Okay, so let's say this is a bridge ID and switch 5 had the lowest one. Now I can make switch 1 and switch 2 the better switches or the best switches by somehow manipulating the bridge ID. If I make them lower, then I will get the root bridge roles to this. Okay, this will be taken down. So the new roles will be coming here. But what can I change? So basically MAC address is a unique ID. I cannot change. So I have to change the priority. Okay. Now there are two ways to change the priority. One, just make use of numbers. Okay. I'll tell you how do we change that. So let's say when I'm going to the first switch number 1, when I go to configuration T, and let's say spanning tree VLAN 1, the priority has to be changed. By default, it is 32768. If I just lower anything below 32768, this switch will become the root bridge. Okay. So let's take 4096, which is a lower value, 4096. Okay, and now if I see the show spanning tree protocol, it has taken the root bridge election. Now switch 5 is no longer a spanning tree root bridge. Okay, so you can see it's no longer root bridge. Earlier it was a root, but now it's not. The reason is I have decreased the priority of this device. So this was one way I could change this. Now the problem, I don't say problem, I say that if I want to have some better intelligent way to do this, so what I can do is, so let's revert back this. If I revert back this, so my switch number 5 must take it back. Okay, so do we have that? Let me once I think it will not quit its behavior. Okay, because it's already taken that. So I want to show you one more way of changing the priority, that is by setting it primary. So let's say if I say spanning tree VLAN 1, instead of priority, if I take the root command and I set it primary. Okay, so what happens? I mean, when I set primary, I know it will change my default behavior. It will change the bridge ID. But how is it changing? On what numbers the bridge ID is getting changed, or on what number the priority is getting changed? So let's quickly check that. So when I did that, it reduced by some extent. Okay. So what extent it reduced is, so that is also documented. In case when you're practicing yourself, you have everything on your workbook. So let's say when I have 32768, when I set one of the switch to be primary, it by default made it 24576. Okay. Now what is that value? So I have 32768 minus 24756. Okay, so it was decreased by this value. Now this is multiplication of 4096. Okay, this is a default behavior of a primary word. When you make use of primary, it is going to decrease by 8192 from the original value, that is 32768. Now you might be also in a position where you want the second switch to be considered as a secondary role. That means let me show you directly on the screenshot. So as we know, one of the lower end devices was taken the root bridge. Now with the help of primary command, I set this as a root bridge and it just lowered the value by 8192 subtracted by 32768. I got some value and it's a primary. Now let's say for some reason this goes down one fine day. Now again the election will happen and one of the other devices will take up that. How if I strictly say if this goes down, this has to be the next person who has to take the root bridge election, right? So in that case I used so in that case what I'll do is let's say I used primary here. So in this case I am going to make use of a secondary keyword on the second device. So what I'll do is I'll go to the second box, the switch number 2. Over here I'll go to global configuration mode. I will say spanning tree VLAN 1 root and I'll make secondary. Okay, now what am I expecting in the primary scenario? It's subtracted with 8192. Now I'm making use of secondary. Now again, will it be 8192? It's not going to be 8192. Okay, so let's verify that. What is it then? So now you will see it's 28693. Okay, so this is 8192. Okay, this is different value and this is different value. Okay, so let's say this is my root, which is 2454 and now it is 28. So let's see what is that value now. So if I do 32768 minus 28673, which is equivalent to 4096. Okay, so let me write it neatly. In case of primary and in case of secondary keyword, this was the default value 32768. So on the first keyword it subtracted with 8192 and in the second it subtracted with 4096. So why this is happening is, so in case of failure of the first devices, which was subtracted by 812 and it had the root bridge election. Now which is the second device that is better than the rest of the device, because all rest of the devices are still 32768, right? So this is better because it's lowered by 4096. If this comes up, which is 8192, which is lowered by 8192 from the original value, so this will retake the election and it will win that. Okay, so the one with the lowest priority, that is 24577, will win. In case in the absence of this, the next best one was 28673 and rest are all 32769, 32769, right? So this is how the calculation happen in the primary and secondary keyword. Now if you are still not very familiar with this, I will give you very simple option, that is setting up the number. If these words doesn't help you, then the first approach is simple. What you have to do is you just have to make use of the numbers. Let's say you're talking about the first switch, go straight away to that spanning tree VLAN 1 priority and just set the value. Now you cannot set any random number. Okay, you just cannot set 5000 because you should make use of something which is a multiplication of 4096. Okay, so best practice is your primary, keep it at 0. Okay, something like this, Now the priority is 0. And for the secondary device, okay, secondary best device, just make use of 4096. 4096. Now this is always your best device. If this fails, then you have the second best device, and rest are all as it is, 32768 priority. Now if you check the behavior of this do show spanning tree, so you will see the priority is 1. Why is it 1? Because we set priority 0, but it's still showing 1. The reason is priority formula is added up with your system external ID, and in this case it's a VLAN number, and we are making use of VLAN 1. So basically 0 plus 1 was added and we have 1. Now similar way in the second switch we can see the priority show spanning tree, and the priority is 4097. The reason is 4096 plus 1. So this way we change the STP behavior from the switch point of view, right? Okay, what did I say? So let's go back to this. So from switch point of view, that is, this was the by default this was been elected as root bridge, but switch point of view I changed the behavior. I made this as a primary root bridge and I made this as a secondary root bridge. Now that is clear. I have two commands. Either I can go with the priority command, I can change the numbers, or I can straight away go with primary and secondary and I can change the behavior. Now let's say from the interface point of view, that means I have this switch which is acting as root bridge. Now there is one more switch. Let's eliminate all other switches as of now. I'm eliminating all other switches. I'm just talking about these two switches. This is the root bridge. All the reconvergence has happened already and they have calculated root port, blocking port, etc, etc. Now when I talk about this segment, in this segment also, one will be forwarding, the other one would be blocking. Okay, so basically basis on the last tiebreaker, the neighbor's physical port number, one with the highest will be blocking. So let's say this is 0/2 and 0/3. So in this case, this one will win the election and this one will be block this. Okay, so we can see that behavior by taking the console of the boxes. So as of now, I'll take all other things because I have done that. I have tested it. Now it's between the first switch and the third switch. So on the first device, as you know, it's a root bridge. So root bridge will always have the designated port, that is forwarding port. So all others I'm just turning off to save some CPU. Okay, now it's between switch number 1 and switch number 2. So from switch number 1 point of view, if I do show spanning tree, all will be up because that is the behavior of a root bridge. They are always designated with the forwarding status. But the switch number 3 has to decide now among these two interfaces which is going to be forwarding and which is going to be blocking. So let's see show spanning tree. So as I told you, one with the lowest neighbor physical ID will be forwarding. Okay, so this is forwarding, this one, whereas the second one is blocking. It started blocking. Now my scenario is, let's say this interface which is at this moment forwarding has some issue. It has some cable issue due to some cable flap, or let's say the SFP module has some issue. This physical SFP module has some issue. I want this to be blocked and this has to be forwarded. Okay, so you understood my point, right? It's not about now root bridge. It's about the path selection. If possible, I'll just zoom out. So if you see these two interfaces from between SW1 and SW3, out of two different cables, okay, I hope it's more clear now. This is serving the packet. The first one is serving the packet. Okay, S2 with S2 is serving the packet, and 0/3 with 0/3 is blocking state. Now let's say this physical interface, which is called as SFP module, or the cable between two, has some issue. So for some reason, I want to block that. I want that to be blocked, and I want my STP to allow this interface. Now in this scenario, I have to make some modification. Okay, so in this case, it's not about root bridge selection, because we are not trying to do anything with root bridge. Okay, so let's remove that from the calculation. So we will see the root port now. So basically for this, root port is same, the forwarding switch is same, so that is a tie now. The second option here was to see the forwarding physical interface ID. Now because of that, it selected this and it blocked that. Now I have to change that default behavior. So what I can do is, as you all know, the cost is an important factor. Okay, so between this, the cost was same. The cost is same because they are directly connected. So for this and this, cost is same, which is 4, and for this and this also, cost is same, 4. So I can change that behavior manually. What I will do is, I will reduce the cost for 0/3, so that gets picked up and my 0/2 gets blocked, because that is what is being asked by my management, that to block that and enable the other one. Okay, so for that, refer the second task, which says manipulating port and path cost. Okay, so refer to the workbook. By default, okay, this is in case of different switches. In this diagram, it's between 0/2 and 0/3, 0/2 and 0/3. So in the workbook, it is different. So even in your lab topology, it can be different depending upon the labels and this one. Okay, so you need to know the theoretical approach before doing anything. So as I told you, 0/3 is blocked. Now I want to make this route forwarding, and I want this to be alternative blocked. So what I'll do is, first I will go to switch 3, configuration mode of switch 3. I'll go to interface. I have two interface, so I'll prefer the range command. I will say 2 and 3 should be shut down because I'm making some port changes. When I'm shutting down this particular thing, my STP is also going down. Okay, so once it goes down, now I will change the spanning tree cost for this. So what I'll do is, I'll come out of this. I'll go to my 0/3, which is where I have to reduce the cost. So I'll say spanning tree. Do we have cost? Yeah, we have cost. Now it's asking me for any path cost. By default, I think it's taking 4, right? So I have to give any port value which is less than 4. Then only it will be taken up. So this is 4 and this is 4. Now if I make this as 2, this will be much better. Okay, and it will start forwarding when compared with this. So I will make this as 2. Okay, so it took the command. Let's go back to the range command and we will unshut that. Interface range giga ethernet 0/2 3, and let's do no shut. So once I do no shut, we can see the calculations happening. All the four all the four port states blocking. I can show you that. Show spanning tree. Okay, so if you see this, it's listening state as of now. Okay, so what are the couple of states that we discussed? Listening, learning, forwarding. Okay, it's in the listening state. It will be for 15 seconds, then it will go to learning state. Okay, now it started forwarding. So we changed the behavior of STP with the help of cost value. Okay, so now this is forwarding and this is blocking. So if you see my diagram, the one which was by default considered as the root port and forwarding is now blocking, and we just bought the second one. Now this is not a bad approach. Okay, whatever I did is not a bad approach. It's about your network diagram or network design in the place. In case if this is not functional or if the cable is not good, then obviously you have to do the changes in your network, right? It's not about keeping something in a block state and also you're struggling to send the packet which is getting dropped, or it is creating the slowness issue. So you have to find the culprit. You have to make the changes, tune the settings, and bring the second interface up. Okay, so it's a good thing in your network. It's not about that 02 has to be always forwarding. Even this is a good interface. Only it's how STP is designed with all its inbuilt calculation algorithm to make things simpler. But if your network says that for some reason you have to modify the change, then you should know how to change that. So that was all about this class. Now one thing what I want to show is the transition time. I hope my audio is back. Okay, now one last thing that I want to show you is that 50-second which I was talking about. Okay, which is documented here. So for the STP to come out of disabled to a forwarding, it will go via 50 seconds. How do I show that? Okay, so let me do in this way. So let's say I am enabling some debugs. Okay, so let's say debug spanning tree, and let's go with events. I have enabled this. I'll go to conf t. I'll go to this interface which is at this moment up and which is acting as a route forwarding, right? So this is route forwarding. So what I'll do on this interface is I will shut it down. As soon as I shut it down, that is going down, and my second link should come up. That is this one. This should come up automatically. Okay. But my main approach is not to do to show that, because that is, we know that once this goes down, the second things will come up. But what I want to show you is the transition. The transition is from disabled going to blocking, going to listening, learning, and then forwarding. And how much time does it take? Okay, so let's say show spanning tree on interface gi0/3. Okay, so it will come up in few seconds. Okay, this is shut at this moment. I have to unshut it. Okay, and since I have the debugs in place, so you can see it started up with listening. Okay, so in this state, it's going to be for 15 seconds. It's in the listening state. And what happens in listening state? It will modify the MAC address. The switch still does not forward any network traffic beside BPDUs. Only the BPDU calculations are being sent between 1 and 2. There is no other data packets being sent. Okay, from listening it went to learning state, and listening was this and learning is this. So it was there for 15 seconds. It was again there for 15 seconds, and then finally it came to the forwarding state. And now if I see, this will be in the forwarding state. Okay. So this was about the duration that I wanted to show you in the case of legacy STP. And this is the biggest drawback in an enterprise, because it takes 50 seconds every time for your interface to start forwarding. So in the next class, I will show you RSTP, that is a rapid spanning tree protocol, where we have cut down the 50 second to like only 15 seconds. And I will also show you what are the different calculation terms there. Okay, like how here we had these ports called designated port and root port, blocking port. Over in RSTP, we have two more ports, that is called as alternative port and backup port. Why do we use these two? Are in the case of reconvergence. When I am doing reconvergence, already some ports will be known to me, so I don't have to go through all the transition that was happening in the legacy STP. I know the two backups with me, and I am going to consider them. I'm not going through these 50 seconds of changes. Okay, so there are many plus point in the rapid spanning tree, and industry standard is rapid spanning tree nowadays. We don't make use of the legacy 802.1d in any of the network because of its drawback. The reason why we have to start with the legacy is otherwise we will not able to understand rapid STP. Even the rapid STP has all the similar behavior of the legacy. It's only the timers and some tuning which is being done. Okay, so your RSTP will not have this part. This is different for RSTP. The one which will have is these steps. Okay, so the calculation of root bridge, root port will again be the same. So that is why we starts with spanning tree. We will go to RSTP, and the last flavor of spanning tree will be multiple spanning tree, where we can group VLANs and we can load balance the traffic. Okay, now at this moment, what is happening is even though I have two switches, one is always blocked and one is always forwarding. So that is a drawback, right? The drawback is I'm not able to utilize my both of the link. I'm not using my switches to its maximum potential. Okay, if I remove the concept of STP, yes, they will be both functional, but at the same time there is a risk of looping. Now that is a higher risk than disabling one of the interface. So that is where your MST, we will see it will load balance the traffic. Okay, we will try to see some way to enhance the spanning tree. Okay, so I just covered from STP point of view for the class today, and in case you guys have any doubt, please let me know. I have also documented all the debug commands, the transition that is happening. Okay, so everything is available on the workbook. So if you just go back after the class, if you are practicing on your own, it shouldn't take you any much time to recall what was done in the class and reproduce on your own labs. Okay, so that is how you practice. Don't keep for next week, because then there will be a lot of new topics getting piled up. So do it like on a daily basis or something. It will not take 15 to 20 minutes if you practice on a daily basis. Okay, so any doubts, let me know, and we are good to wind up. I know I took some extra time today.
Hey Sagar, one quick
Yes.
question. So you can't change port priority numbers when manipulating which port goes into forwarding, which port goes into blocking.
So basically the port priority numbers remains fixed, because the numbers that get stacked up, it's something which get fixed up. Okay, so you're talking about this one, right?
128 dot something, 128 dot something.
So I think we can change this, but I'm not.
I think we can change it,
but I'm not sure on which scenarios. Okay, I think in case if you don't want to manipulate with the cost, then might be you have to deal with the priority in that particular.
Correct.
Yeah. So you can change this. Okay, you can change the priority, but yes, this is a constant number which you cannot change it. So let me quickly check this. Okay, regarding the capture of Wireshark, it was just a right click. Okay, so basically you have to bring the switches powered on. Don't you cannot run Wireshark on a turned off switches. So let's say when the switches are green, right click or right click on the interface, just start it up. Okay, so it will start capturing the packets. That is the inbuilt features of GNS. So if you remember, when you install GNS client, it will ask for multiple things with lot of tick marks, right? And I always advise keep as it is, don't untick anything. So one among them was Wireshark, Nmap, Wireshark. So these things will be installed along with your GNS. Yeah, so that was already been disclosed. Okay guys, so any other doubt? So how was the STP topic? I'm pretty sure you guys might be already aware of STP, but is that something which you learned something new for the first time today? How about the beginners, the one who joined for the first time? Are we good? Did you understand the STP concept? Where are the other guys? No one want to interact?
Yeah.
Okay.
It was good. It was unclear.
Okay. Okay, great. So guys, catch up in the next class. Okay. Have a nice day. See you soon. Okay. I guess I got some. Okay. Great. Okay. Okay. Fine, guys. I'll pass on the recordings, and all the workbooks will be loaded up. See you in the next class. Thank you.